Okay, for this next part of the lesson, we're still going to work on scatter plots. Our essential learning will be that I can use scatter plots to make predictions based on the trend of data. So it's using the scatter plot to determine some information and make some predictions. For our first scatter plot here, it says the scatter plot below shows the number of hours of physical activity per day based on your age. So we can see the ages are on the x-axis in years, and the hours per day that someone has spent doing physical activity is on the y-axis. And what we can see here is that we have a trend of data. It's a negative correlation, which tells us that as the ages, the years, increase, or the age increases, the number of hours spent doing physical activity per day decreases. So I'm going to go ahead and put a line of best fit on here. This line of fit really helps us make predictions because it follows this trend of data. So I'll draw in my line of fit. And now when I go to answer this question, it says, based on this scatter plot, what will the daily amount of physical activity be for a person who is 50 years old? So we have to go look at 50 years old, which is right here. Now, before I put the line of best fit on there, it looked like this. So for 50 years old, I really would have to follow this trend of data and estimate that it's somewhere right around here, around 2, in between 2 and 3 hours. My line of fit really can help me narrow that down a lot better, because if I know 50 years is right here, 45, 50, these are going by fives, I can see that my line hits right about at 2 hours. So this line of fit really helps us make that prediction pretty accurately. For the next question, it says the scatter plot below shows the amount of money Abby has in her bank account over the course of a few weeks. Based on the scatter plot, how much money should Abby have in her account at 3 weeks? So we see that weeks is on the x-axis and money is on the y-axis. And the question is asking us for 3 weeks. So if I go over to 3 weeks and up, I see that there are no points at 3 weeks, but it's probably somewhere in this a range. Around, you can see around $60, a little bit below, a little bit above $60, but it's got to follow that trend of data. So if we draw in our line of fit, we can see that it really kind of fits the data right about $60. So if you said a little bit below $60 or a little bit above $60, that would be pretty accurate. It's just an estimate, and remember that line of fit really just kind of estimates the amount anyways, because it's a scatter plot. All the points are not exactly on the line. So our line of fit helped us estimate that in 3 weeks, Abby will have about $60. For the next question, it says the experiment results from Sarah's science project are shown below. Based on the results, how much bacteria would you expect at 2 hours of sunlight? So we can see on the x-axis we have the number of bacteria, and on the y-axis we have the amount of sunlight in hours. And we're looking for 2 hours of sunlight, about how much bacteria would be in her experiment results. So it's somewhere in this range. So what I'm going to do is I'm going to draw in the line of fit, and then I'm going to have you take a couple seconds to estimate the amount of bacteria in there. So without the line of fit, it's pretty open somewhere in this range. So here's your line of fit. Take a couple seconds to figure out what your estimate would be based off that line of fit. Okay, what you should have noticed is that for 2 hours of sunlight, if you follow over horizontally, you hit the line right about here. Okay, and that's for about 2 hours. So then when I go down, I can see it's in between 250 and 300, really right about in the middle there. So we would expect that's about 275 parts of bacteria in her results after 2 hours. Okay, one more practice problem. This question says, Ben collected data from a group of 12 people. He measured each person's resting heart rate and recorded the average number of hours each person exercised per week. He created a scatter plot to show the data he collected. Based on the scatter plot, what is the best prediction of the resting heart rate in beats per minute of a person who exercises an average of 10 hours each week? So it's kind of difficult to estimate 10 hours because the trend of data is so far away, but I'll draw in the line of fit and then you can estimate what you think 10 hours would be. Okay, there's your line of fit. Take a couple seconds to predict the resting heart rate based off of 10 hours of exercise per week. So we can see if we go to 10 hours of exercise and I look at my line of fit, 10 hours of exercise lands on the line right about here. And so if I follow that over, it's in between 30 and 40, but it's definitely closer to 40. So saying something around 37 or 38 beats per minute would be appropriate. Remember, if you estimated a little bit above or a little bit below the line, that would be fine too, because it is a scatter plot, but we can see these points are pretty close to the line. So your estimate should be really close to this line. Okay, and the last piece that I want to go over with you is how to make precise predictions. So this problem says the table in Scatterplot shows the number of people who have attended a hot air balloon festival over an 8-year period. So this table was plotted on the Scatterplot and the line of best fit was drawn in. Now, if you think back to chapter 4, we had these lines on graphs and we did all sorts of things with them. One thing that we did was we wrote an equation for that line. The equation is super helpful in making predictions. So what I'm just going to quickly refresh with you is how to write this equation from the line, and then we're going to use that equation to make predictions. So 2 pieces we need to write the equation. We need the slope and the y-intercept. So if I'm looking for the slope, I'm looking for rise over run. So I'm going to find 2 points on this line where I could find the slope. So I see a point right here, right on my line, where it crosses the grid at 3,800. And then I see another one where it crosses really close at 1,600. So I'm going to use those 2 points to create my slope triangle, my rise over my run. So I'm going to rise and run. Now when I rose, I didn't rise 2. Yes, it's 2 units, but these are counting by 400s. So I actually rose 800. And when I ran 1, 2, 3 years. So my slope fraction would be 800, rise 800, run 3. And when I simplify that, I need to do 800 divided by 3, and that equals 266.6 repeating. So I'll round that to 266.7. So this is our slope. Then for our y-intercept. Now the y-intercept is where the line crosses the y-axis, which is right way down here at 0. So our y-intercept is 0. So when we write the equation, remember we use y equals mx plus b. So I always start with y equals, and then instead of m, I replace it with my slope, 266.7 x plus b, which is 0. So I don't need to write plus 0 in my equation. So now we're going to use this equation to make some predictions. Okay, now the last part we're going to look at is the part in yellow. It says use the line of fit to make a prediction about how many people would have attended the festival at 14 years. So this is our line of fit. 14 years though is way off the graph. So we're actually going to use the equation of the line of fit. And because I know years is x, I can plug in 14 in for x. So 14 years is going to replace x. So I'm going to take 266.7 and multiply it by 14 years to make my prediction. So if I use my calculator and do 266.7 times 14 years, that gives me 3,733.8. So I'll round that up to 3,734. 3,734 people. Okay, now this equation was super helpful because, like I said earlier, 14 years would be way off of our graph and it would probably be somewhere up here. So it's really hard to make a prediction if it's not on the graph, which is why the equation is useful.